In this video, we're going to review the importance of the structure of the atom, and specifically the importance of what column A's mean and rows mean. So in our notes, we will title this as atomic structure. And what I want to remind you about is the importance of what the row indicates to us, as well as the A column on the periodic table. So the first thing is the A column. For the atomic structure, the A column equals the number of outer electrons for that specific element. It gives us the number of outer electrons. Now, I do want to remind you that, so we'll go note, outer electrons equals valence electrons, which also equals the bonding electrons. So we use that one phrase to mean all three of these. And then the row number equals the number of energy levels for that specific element. Now, once again, a note, the energy level, the row number and the is also referred to as the period. So if it's row number 1, it's also period 1. So if we look at an atom real quickly, we should be able to find out how many valence electrons it has and how many energy levels it has. So for instance, if we looked at nitrogen, we would immediately be able to go to column 5A and know it has 5 electrons on the outside, and slide over and know that it has 2 energy levels. Now, also I want you to add in the importance of outer electrons. As atoms, and I'll use the word bump into other atoms, so as atoms bump into other atoms, it is the outside of the atom that is going to connect or bond. It's the outside of the atom that is going to connect or bond. So as these atoms are flying around bumping into each other, the most important part of the atom is the outside. The most important part of the atom is the outside, because that's the part that's going to connect or bond. So once again, let's say we're talking about chlorine. Immediately, once you know where chlorine is, you know that it'll have 7 electrons on the outside because it's in column 7A. Yes, it has 17 protons in the nucleus and 17 electrons in the electron cloud. But the most important thing that you can tell me is, of those 17 electrons, 7 of them are going to be on the outside of the atom, And those 7 are on the outside in energy level number 3. How about calcium? Yes, calcium has 20 protons and 20 electrons, but the most important part is of those 20 electrons, 2 of them will be in energy level number 4. 2 of them will be on the outside in energy level number 4. The most important part of the atom is the outside of the atom. The most important part of the atom is the number of electrons on the last energy level. The most important part of the atom are the outer electrons or valence electrons or bonding electrons. That is the most important part of the atom. The last energy level. If there's only one piece of information that you would want about any one of these atoms, is how many electrons are going to be on the outside of the atom. That is the most important piece of information. If we picked krypton, yes, krypton has 36 protons in the nucleus and 36 electrons arranged outside the nucleus. That's important. It's not the most important. The most important thing about krypton is that it's in column 8A, so it has 8 valence electrons, and it's in row number 4 for 4 energy levels. 8A, 8 valence electrons, is the most important thing that I can know about argon, or krypton, excuse me. Or argon and krypton both have 8 valence electrons. Now, notice we're only dealing with the A columns right now. That means we are skipping all of these B, so we don't need to worry about the B columns and how many valence electrons. We will be concerned about those later. Now, the next thing that I do want to point out is the number of electrons within an energy level is determined by, and I should say the maximum, not just the number, but the maximum. That's important. The maximum number of electrons within an energy level is determined by the number of the energy level, the maximum number of electrons. So, energy level number 1, maximum of 2 electrons. Energy level number 2, 3, 4, 5, 6, and 7. Each one of these, there's a maximum of 8 electrons. Energy level number 3, maximum of 8 electrons. And then these we will get to later as we go through. But right now, you need to understand energy level number 1 can only hold 2 electrons. Energy level number 2 can only hold 8. Energy level number 3 can only hold 8. That's the maximum it can hold. And then, this is important. Each atom desires to have a maximum, I'll call full outer energy level. Each atom desires to have a maximum or full outer energy level. Atoms will either gain, lose, or share electrons in order to have all of its energy levels full. And I want to remind you, we previously drew, and I'll just draw this real quick, we previously drew the periodic table. I'm sure you drew it much better than I did. And we labeled this side as non-metals. And if you remember, we said non-metals gain electrons, and we labeled this side as metals, and we said that metals will lose electrons, and we had to label this as the same color as these guys over here, because it really belonged on the non-metal side. It was just on the metal side. But, and there's reasons it has to be listed on the metal side, because it's hydrogen. It has one electron on the outside, so we have to put it in column 1A. So what we're going to find out, what we're transitioning into, are looking at metals that are wanting to lose electrons in order to have a full outer energy level, or non-metals that are going to be gaining electrons in order to have a full outer energy level. I hope this helps in understanding columns and rows, the importance of columns and rows, and how it relates to the atomic structure, and then beginning to understand this idea that atoms are going to want to change. Atoms are going to want to change the outside structure in order to have a full outer energy level. And for a full outer energy level, right now we know energy level number 1 wants 2 electrons. Energy level 2 and 3 both want 8 electrons.